Hey, hi everyone, how are you? So in today's class, let's continue with geometry. So this is video number 2. So let's start. Okay, so today we will be doing triangles, some important types of triangles, properties, and some theorems. Also, we'll be touching upon quadrilaterals and its properties. So let's start. So first we have equilateral triangles. As we already know, what is an equilateral triangle? जहाँ पे तीनों sides are equal, right? If you remember, this we have done in the first concept video. This is side A, this is side A, this is side A, right? So there are some important properties of equilateral triangle. We know that each angle of equilateral triangle is equal. So if the sum of the angles of a triangle is 180 degree and all three angles are equal, so each angle of an equilateral triangle will be 60 degrees. We know the sides are equal, the angles are equal. Now, area of an equilateral triangle, we have a standard formula as root 3 by 4 into a square, where a is the side of the triangle. Also, there is a concept that if a perimeter of a triangle is given, say a perimeter of a triangle equals to p units. Now, equilateral triangle will be the only triangle with a perimeter p which has the maximum area. That means अगर हमारे पास एक isosceles triangle है या फिर scalene triangle है या फिर equilateral triangle है जिसमें हर triangle का perimeter is constant, say p units, say 10 centimeter है या 20 centimeters है, so using that perimeter given, we can infer that equilateral triangle will be the only triangle with the maximum area. So maximum area will be of equilateral triangle, right? So there is one more concept. Actually, I wanted to share it a bit further, but चलो यहाँ पे कर बता देते हैं कि this is a triangle ABC. If I draw the angle bisector of each angle bisector मतलब angle को जो half कर दे equal parts. So angle bisector of angle A looks like something like this, where this angle equals to this angle. Angle bisector of angle B looks like something like this, where this angle and this angle are same, and angle bisector of angle C looks like something like this, right? So ये तीनों angle bisector जहाँ meet करता है, this is called incentre. So let's say this is point D. So D is my incentre, right? Also again, मैं वापस एक triangle लेता हूँ and let's call it triangle PQR. Now, if I try to draw a perpendicular bisector of each of the three sides, perpendicular bisector मतलब any line which bisects the side and is perpendicular to it. So for example, QR का perpendicular bisector will look something like this. So this side equals to this side and this is 90 degrees. PQ का perpendicular bisector will look something like this. And PR का perpendicular bisector will look something like this. Right? So this point where all the three perpendicular bisectors meet is called circumcentre. So what I want to share with you is in equilateral triangle, incentre and circumcentre, they coincide with each other. मतलब the point of meeting of angle bisectors and the common point of meeting, which is the intersection point of perpendicular bisectors, is same in equilateral triangle. Okay. I also want to share one of the important property of equilateral triangle. So let's see. Say this is an equilateral triangle ABC, and let's say AD is the median of the equilateral triangle. Right. Now we can observe that AB is A, then AC is also A. Similarly, BC is also A. If BC is A, AD is median. We know median divides the side into two equal parts. So BD equals to A by 2, CD equals to A by 2. Right. Now, if we see in triangle ABD and triangle ACD, we see that AB equals to AC, right? BD equals to CD equals to A by 2, right? And AD is the common side. So we can say that triangle ABD is congruent to triangle ACD. If these two triangles are congruent, then these two angles are also same. which is 90 degree, since this is a straight line. So we can say that AD is not only the median, but AD is also the perpendicular bisector. As we have already seen, perpendicular bisector divides the line into two equal parts and is perpendicular to it. Also, we can say that angle BAD, which is this angle, is same as angle DAC, right? So we can say that AD is also the angle bisector. So this is a unique property of an equilateral triangle. You can use this in questions, right? Also, I want to share with you guys. Suppose यहाँ पे हमारा वो incentre या फिर circumcentre है. Equilateral triangle में दोनों coincident होते हैं. So let's call this point as O. So I want to say that this point O divides the line AD, which is my perpendicular bisector or median or angle bisector, in the ratio of 2:1. This is an important property of a equilateral triangle. जहाँ पे मेरा circumcenter या फिर incentre जो भी point है, this divides my median or the angle bisector or the perpendicular bisector in the ratio 2:1. This is an important property. So please remember. Now let's move on to the next type of triangle, which is my isosceles triangle. So isosceles triangle में हम जानते हैं कि ऐसा triangle जिसमें दो sides same है and the third side is different. So let's say this is my isosceles triangle, and let's say the name of the triangle is ABC, where AB and AC are equal to A and BC equals to B, where A not equal to B, right? This is my isosceles triangle. In isosceles triangle, आपको प्रॉपर्टी क्या याद रखनी है? एक है एरिया ऑफ आइसोसेलेस ट्रायंगल, which equals to b by 4 into root under 4a square minus b square, right? This is a very simple formula. Sometimes question पूछ सकता है isosceles triangle का area, so you should be aware of this formula. दूसरा thing, if two sides are equal, then the angle opposite to the sides are also equal, which means if AB equals to AC, then angle B equals to angle C, right? So this angle equals to this angle. Super clear? So ये दो properties हो गई isosceles triangle. Let's move on to the third type of triangle, which is the right angle triangle. Okay, so right angle triangle क्या होता है? We know that one of the angle is 90 degrees, right? And the other two angles are acute angles. So let's say this is a right angle triangle, and let's call it A, B, C, where angle B is 90 degrees, right? So there is an important theorem called Pythagoras theorem. So in Pythagoras theorem, we know AB square plus BC square equals to AC square. That is, the sum of the square of the other two sides equals to the square of hypotenuse. So ये एक important theorem आप याद रखिएगा. Right? Hypotenuse is the biggest side of a right angle triangle. So AC is my hypotenuse. BC is usually called base, and AB is my perpendicular. Right. So there is one more important property which sometimes is asked in exams. So suppose एक आपको एक right angle triangle दिया हुआ है. Let's call it ABC, where B is right at 90 degrees. And suppose angle B say towards side AC, BD is a line such that BD is perpendicular to side AC. आपको questions में क्या दिया सकता है? Suppose AB का length is say 6 centimeters, BC का length is say 8 centimeters, and say BD का length is 4 centimeters. Find, let's say, CD, or let's say find any other side. कुछ भी दिया जा सकता है. So इसको solve करने का एक तरीका है. Triangle ABC and triangle BDC, right? So इस triangles में अगर आप देखोगे इन दोनों triangles में, we know that angle ABC equals to angle BDC, right? Angle ACB equal to angle BCD. So अगर दो angles equal है तो automatically third angle भी equal होगा, वेरी क्लियर. अगर दो ट्राइंगल्स है, अगर आपको दोनों ट्राइंगल्स के दो एंगल्स इक्वल है तो तीसरा एंगल ऑब्वियसली विल बी इक्वल. यू कैन जस्ट क्रॉस चेक इट. सो कैन आई से if three angles if all the angles of the two triangles are equal, then triangle ABC is similar to triangle BDC. If two triangles are similar, हम जानते हैं properties of triangle में that AB by BC equals to BD by CD. कह सकते हैं AB आपको क्या दिया हुआ है 6, BC क्या दिया हुआ है 8, इक्वल्स टू BD इक्वल्स टू 4, CD क्या दिया हुआ है, CD हमें निकालना है. तो CD आ जाएगा वैल्यू 8 into 4 by 6, which is nothing but 16 by 3 centimeters. So using this property that these two triangles are similar, आप कुछ missing values निकाल सकते हो, right? Now let's move on to the next topic. Important terms with respect to triangle. Okay, so some of the important terms like incentre, circumcentre हम already cover कर चुके हैं. Now let's come to the application part. Let's start with median. So median हम जानते हैं what is a median? It divides a side into two equal parts. Let's say ये एक triangle है ABC and इसके ये तीन medians है, namely AD, BE and CF. They meet at this point O. Point O is called centroid. Centroid का एक यूनिक प्रॉपर्टी है, centroid of any triangle, isosceles, equilateral, scalene, कोई भी triangle हो, centroid divides a triangle into 6 equal parts. That is this part, this part, this part, this part, this part and this part. This all 6 parts are equal. So centroid divides a triangle into 6 equal parts. Right. और एक बात है, आपका मीडियंस के साथ एक प्रॉपर्टी भी है. सो इन दिस ट्रायंगल ABC माय मीडियंस आर AD, BE and CF are my medians. So 3 into sum of side square, which is AB square plus BC square plus AC square, equals to 4 into sum of median square, which is AD square plus BE square plus CF square. This is an important property. It's rarely asked, but I think you should still know it कि medians का क्या property with respect to its sides, right? So ये हुआ median का. Next come to altitudes. Altitude क्या होता है? So let's see with this example. This is a triangle ABC. So AD is an altitude on side BC if angle ADB equals to angle ADC equals to 90 degree. So any perpendicular drawn on a side from its opposite vertex is called an altitude. So let's say this is a triangle ABC. So altitude is any line drawn from a opposite vertex on a side such that it is at 90 degrees. Now if I say this AD is perpendicular to side BC, then AD is an altitude of the triangle ABC with respect to side BC. Similarly, let's say BE is an altitude and CF is an altitude, right? So the intersection point of three altitudes is called orthocentre. So this meeting point O is called the orthocentre here. There is an important property with respect to orthocentre. So in case of any altitude related sum आपको कभी भी दिया रहेगा, then always remember angle BOC plus angle BAC equals to 180 degree. मतलब angle subtended at the orthocenter plus the vertex angle are supplementary in nature, right? These two properties you should remember. Now let's see the third important term, which is perpendicular bisector. Okay, so here हमने पहले सीख लिया what is a perpendicular bisector. Any line which bisects the side and is perpendicular to it is called perpendicular bisector. So I'm again explaining here. So this is a triangle ABC. If this is my perpendicular bisector to side BC, this is a perpendicular bisector to side AB, and this is a perpendicular bisector which to side AC, then this point, the intersection point, let's call it as O. Intersection point O is called the circumcentre. Right. So there is also an important property with respect to circumcentre, that is angle BOC equals to 2 into the vertex angle. So angle subtended at the circumcenter is twice the vertex angle. This is an important property of a perpendicular bisector. Now let's move on to the next important term, angle bisector. This also we have done. So if this is a triangle ABC, and let's say these are the three angle bisectors, and let's say they meet at point O. So the intersection point of the angle bisectors is called incentre. Here also there is a unique property of incentre. So angle BOC equals to 90 degrees plus half into the vertex angle, which is angle A. So to summarize, हमारे पास क्या क्या है? Terminology, intersection point, relationship between angle subtended at the intersection point and the vertex angle, right? So let's say one by one. We have altitude. If altitude intersect, they meet at orthocenter. और orthocenter में हमारा फॉर्मूला क्या था? They are supplementary. So angle BOC plus angle A equals to 180 degrees. Next क्या था हमारा? Perpendicular bisector. Perpendicular bisector में क्या था? They meet at circumcenter. Circumcenter का क्या relation था? Angle BOC equals to 2 into the vertex angle. Right. Third क्या था? Angle bisector. Angle bisectors meet at incentre. Incentre relation क्या था? Angle BOC equals to 90 degrees plus half angle A. So this table will help you to remember these all three formulas very easily. Let's move on to the next topic. Theorems related to triangle. So in theorems, we'll be studying about three important theorems related to triangles. First is the midpoint theorem, second is Apollonius theorem, and third is the angle bisector theorem. So let's see one by one. So in midpoint theorem में क्या बोलता है? Let's say this is a triangle ABC. And let's say AB का midpoint is here, point D, and AC का midpoint is here, point E. So if I join these two midpoints, so DE will be half the third side. Half the third side क्या है? BC. And DE will also be parallel to the third side. So midpoint theorem ये बोलता है, if you join the midpoints of two sides of a triangle, it will be the half of the third side and parallel to the third side, right? Now let's move on to the next theorem. आपको थ्योरम का नाम याद रखना नहीं है, बट थ्योरम क्या है उसका एप्लीकेशन आना चाहिए, राइट? सो इन Apollonius theorem, let's say this is a triangle ABC, and let's say AD is the median. So AB square plus AC square equals to 2 into BD square plus AD square. ये कुछ कुछ क्वेश्चंस में यूज होता है, सो इसे याद रखिएगा. इसको याद करने का ट्रिक मैं बताता हूँ. सपोज these two triangles are congruent, ठीक है? सो ये 90 डिग्री है, ये भी 90 डिग्री है. दिस इज जस्ट एन assumption इस फॉर्मूला को याद रखने के लिए. इट्स नॉट नेसेसरी कि 90 डिग्रीज या ये congruent हो. सो अगर ये congruent triangles है तो ये दोनों एंगल्स 90 डिग्री होंगे. और आपको पाइथागोरस थ्योरम में मैंने सिखाया था कि the sum of two sides का square is equals to hypotenuse का square. So in this triangle ABD, AD square plus BD square equals to AB square, right? Similarly in triangle ACD, AD square plus CD square equals to AC square, right? अब आप ये दो इक्वेशंस को ऐड कर दोगे, सो आपका आएगा AB square plus AC square RHS में, और LHS में this whole thing का sum is nothing but this 2 into BD square plus AD square. You can remember this formula like this also. So this is the Apollonius theorem. Let's move on to the angle bisector theorem. So angle bisector theorem में क्या बोलता है? Let's say this is a triangle A B C. So let's say this is the angle bisector AD, where angle BAD equals to angle CAD, right? So angle bisector theorem बोलता है AB by BD equals to AC by CD, which is nothing but this side by this side equals to this side by this side, right? इसको याद रखना easy है. This is my angle bisector theorem. कभी कभी sums में use आता है. When we'll be doing the practice video, we'll be seeing the application. Okay. Before moving on to the next topic, I want to share with you some more important terms based on the concepts which we have already done till now. So let's say एक triangle हमारे पास ABC, BC, इसमें आपका AD, BE and CF, these are all my angle bisectors. So this intersection point is in center, ये हमें पता है. So if I draw a circle with radius at point O, and OE, OF and OD are my radius which is equal, then this entire circle is called incircle. Similarly, अगर मैं triangle का circumcentre use करके circle बनाता हूँ, which is circumscribing this entire triangle. Here let's say this point is O dash. So O dash is my circumcenter, and the circle which is circumscribing the triangle is circumcircle, right? ओके, सो हम पहले से जानते थे कि एरिया ऑफ ट्राइंगल के कुछ इंपॉर्टेंट फॉर्मूलाज होते हैं. लेट्स सी वन बाय वन. एरिया ऑफ ट्राइंगल हम जानते थे हाफ इंटू बेस इंटू हाइट, ये एक फॉर्मूला है. सेकेंड फॉर्मूला क्या है? हाफ इंटू सम ऑफ टू साइड्स इंटू साइन थीटा, वेयर थीटा इज द एंगल बिटवीन द टू साइड्स ए एंड बी. थर्ड क्या है? हीरोन्स फॉर्मूला. इफ यू रिमेंबर, हीरोन्स फॉर्मूला क्या है? रूट अंडर s into s minus a into s minus b into s minus c, where s is semi perimeter. Right. इसके बाद फोर्थ में द एरिया ऑफ ट्रायंगल इज ऑल्सो आर एस, जहां पे आर आपका इन रेडियस होगा. अभी हमने इन सेंटर पढ़ा था ना, तो उसी का जो रेडियस है, आई मीन दिस वन, दिस ओ डी, ओ ई एंड ओ एफ, इसको इन रेडियस बोलते हैं. सो इन रेडियस इंटू सेमी पेरीमीटर, एस आपका सेमी पेरीमीटर ही है. राइट. फिफ्थ है ABC by 4R, where capital R is my circumradius. जिस तरह एंगल बाइसेक्टर का जो इन रेडियस हम निकाले थे, उसी तरह सर्कम सेंटर में से सर्कम रेडियस आएगा. सर्कम रेडियस आपका हो गया इस तरह से, यहाँ से दिस इज माय सर्कम रेडियस, दिस इज माय सर्कम रेडियस. राइट. सो आई कॉल दिस 5 फॉर्मूलाज एज सुपर 5 फॉर्मूलाज. जब भी एरिया क्वेश्चन दिया रहे, आपके दिमाग में तुरंत ये 5 फॉर्मूलाज खुलना चाहिए. ये 5 फॉर्मूलाज आपको कितने सम्स में हेल्प करेंगे आपको आइडिया भी नहीं है. सो जस्ट रिमेंबर दिस 5 फॉर्मूलाज फॉर एरिया ऑफ ट्रायंगल्स. राइट. आई कॉल दिस 5 formulas, 5 super 5 formulas. Okay, so let's move on to the next topic, which is quadrilaterals. So quadrilateral is any polygon having 4 sides. So let's say we have a quadrilateral like this, A, B, C, D. So ABCD is a quadrilateral, and we call AC and BD as its diagonals, right? AC and BD. Let's say AC is diagonal 1, BD is diagonal 2. AB, BC, CD and D are the sides, and AC and BD are its diagonals. So let's say the diagonals intersect at point O and they make an angle of theta. So area of quadrilateral ABCD equals to half into product of diagonals into sine theta. This is one property. Next is, say again in this quadrilateral, let's say from point C I'm drawing a perpendicular on diagonal BD, and again from point A I'm drawing a perpendicular to diagonal BD. Let's call these two perpendiculars as P1 and P2. So I can write area of quadrilateral ABCD equals to sum of areas of triangle BCD and triangle ABD. I can write that. Now triangle BCD का एरिया क्या होगा? हाफ इंटू बेस इंटू हाइट. सो BCD का बेस क्या है? BD, और हाइट क्या है? P1, राइट. एंड ABD का बेस क्या है? BD, एंड हाइट क्या है? P2. So we can write that sum of areas of triangle BCD and ABD as half into diagonal BD into sum of perpendiculars on it. This is again an important formula. So we have seen दो formulas. एक है area of quadrilateral equals to half into product of diagonals into sin theta, and दूसरा formula क्या है area का? half into diagonal एनी वन D1 या D2, और उस डायगोनल पे आपको परपेंडिकुलर्स के सम चाहिए फ्रॉम अपोजिट वर्टिसेस. सो सम ऑफ परपेंडिकुलर्स ऑन इट. ओके, सो मुझे आपके साथ दो कंसेप्ट और डिस्कस करना है रिगार्डिंग सर्कमस्क्राइब्ड क्वाड्रिलेटरल एंड इंस्क्राइब्ड क्वाड्रिलेटरल. सो सपोज ये क्वाड्रिलेटरल है ABCD, और this is circumscribing a circle, then ABCD is called a circumscribed quadrilateral. वहीं पे एक और quadrilateral है, let's call it PQRS, and PQRS is being circumscribed by a circle. So this quadrilateral is inscribed in a circle, so this is called a inscribed quadrilateral, right? अब circumscribed quadrilateral में एक फॉर्मूला है एरिया का. So area of a circumscribed quadrilateral is root under S minus A into S minus B into S minus C into S minus D. A, B, C, D are the lengths of the four sides of the quadrilateral, or S is my semi-perimeter. A plus B plus C plus D by 2. Inscribed quadrilateral में एक फॉर्मूला है which is called Ptolemy's theorem. Ptolemy's theorem क्या बोलता है? The product of the diagonals of a inscribed quadrilateral. So PQRS में ये तो दो diagonals है. So PR into QS equals to PR plus QS, where PR and PQRS are the relative sides of the quadrilateral. Let's call it PQRS. So this is my Ptolemy's theorem. This is my area of quadrilateral, which is a circumscribed quadrilateral. Right. Now let's see the types of quadrilaterals. Okay. So here we have several types of quadrilaterals. Let's start with parallelogram. So parallelogram में we have a quadrilateral. Let's call it ABCD, where the opposite sides are not only parallel to each other but also equal. So here I mean AB equals to CD and AB is parallel to CD. Also BC equals to AD and BC parallel to AD. So if these two properties are being satisfied, then it is a parallelogram. Now area of parallelogram. So parallelogram is also denoted like this. Area of parallelogram ABCD equals to AB into BC into sine theta. Product of two consecutive sides and the angle between them, right? Sine theta. If this is theta, so this is my area. So अगर आप product of two consecutive sides कर दोगे and the angle between them means the sine theta, you will get the area of parallelogram. Also, area of parallelogram is base into height. So if I call AB as my base and let's say this is my height, right? So base into height is also area of parallelogram, right? These two will be the same values. To rectangle. So a rectangle looks something like this. A rectangle is also a parallelogram, but the angle between any two consecutive sides is perpendicular, is 90 degrees, right? And the diagonals are also equal. So AC equals to BD. You can check this by Pythagoras theorem. The diagonals are equal. Right. Also, there is an important saying: all rectangles are parallelogram, but all parallelogram are not rectangles. Right. Now let's move on to the third type of quadrilateral, which is called rhombus. आप सब बर्फी खाते होंगे. द बेस्ट एग्जाम्पल ऑफ rhombus. सो rhombus कैसे दिखता है? जस्ट द शेप ऑफ अ बर्फी. A B C D is a rhombus where AB equals to BC equals to CD equals to DA. All the four sides are equal. Diagonals AC and BD, which is this and this, are not equal. So area of rhombus क्या होगा? Area of rhombus ABCD equals to half into D1 into D2 into sin theta. So एक और प्रॉपर्टी क्या है कि diagonals of a rhombus intersect at right angles. So this theta will be 90 degrees. If you remember, हम first concept video में किए थे कि sin 90 degree is 1. So I can rewrite this as half into d1 d2 into sin 90, or this is equals to half into product of diagonals. So this is my area of rhombus. सो रोम्बस में और एक चीज मुझे आपको बताना है कि आपको रोम्बस देखते हुए काइट का भी ध्यान आएगा. बट काइट इज नॉट अ रोम्बस बिकॉज रोम्बस में चारों साइड्स इक्वल है. बट काइट में ओनली टू पेयर्स ऑफ साइड्स आर इक्वल. मतलब काइट में इट विल बी लुकिंग समथिंग लाइक दिस. So if this is my kite A, B, C, D, so AB and AD are equal and BC and CD are equal, but these two pairs are not equal to each other, right? But इसका भी formula जो area का है, this will be same as half into product of two diagonals, right? Because ये भी intersect at 90 degree करता है. Next, we can speak about squares. So square ऐसा दिखता है. Again, यहाँ भी all four sides are equal. Let's call this square as ABCD. So AB equals to BC equals to CD equals to DA, and the adjacent sides of the square is also perpendicular to each other. मतलब these all angles are 90 degrees. Right. We have a property area of square equals to a square, where a is the length of any side. Right. Also, diagonals of a square are equal. So यहाँ पे AC equals to BD हो जाएगा. So there is an important saying: all squares are rhombus, but all rhombus are not square. Right. So these are some of the important properties of a square. Right. Now let's move on to the last quadrilateral, which is a trapezium. So trapezium looks something like this, where only one pair of sides are parallel to each other. So let's say in this trapezium ABCD, AB is parallel to CD. So ABCD is a trapezium. Now there are some important properties related to trapezium. First, let's say area. So area of a trapezium is half into sum of parallel sides into height. So let's say if this is the height of the trapezium, so this the formula of area क्या हो जाएगा? Half into AB plus CD into height. Let's say this is denoted as H. Okay. Also, जो diagonals of trapezium है, let's again draw it here. They are in proportion. So if this is the trapezium ABCD, so जब diagonals intersect each other, let's say point O, then AB by CD equals to OA by OC equals to OB by OD. Right. So ये एक important property है regarding intersection of the diagonals of a trapezium. Okay. Okay. So let's move on to the topic hexagons. So hexagon is a polygon with 6 sides. So let's draw a regular hexagon with all 6 sides equal. Okay. Let's call it hexagon A, B, C, D, E, F. If I join the opposite ends of A and D, C and F, and E and B, so the resulting figure, I get 6 parts. This 6 parts is nothing but 6 equilateral triangles. So a hexagon is nothing but 6 equilateral triangle. So दिया क्या रहेगा? आपको कोई भी एक साइड का लेंथ दे दिया जाएगा और एरिया ऑफ हेक्सागन निकालने बोला जाएगा. सो एरिया ऑफ हेक्सागन विल नथिंग बट 6 into एरिया ऑफ इक्विलेटरल ट्रायंगल्स. So 6 into root 3 by 4 a square, right? This is my hexagon. I hope you liked today's class. So stay tuned. Please like, share and subscribe my channel, and have a very great day ahead.